Hello and welcome back to another session of Google.rs. It's Byron speaking, and we are back with cargo. And while playing this catch game here, I think I want to do this in Piston because it should just be simple enough to do this. Also, no, I will not be too distracted about that. Because after all, there's more to be done and I have to finish these things at some point. And it seems that all the code is here. Simple enough, huh? Phew. But it should be doable to just port it in a stupid fashion. And that's really what I would like to do. Yeah, totally. But let's see. That said, back to business. So this doesn't work. Locking Rust C doesn't work at all. There's more to it that I probably am missing entirely. And the new idea is to lock on JobQueue level. Because per JobQueue, let's see how this, because I know there are job queues of different kinds. Self queue, queue, dependency queue. Yeah, so this dependency queue thing is what we are interested in. And this is what is returned when they ask for a queue for a package at a certain stage. Even per stage. And that's the dependency queue. So let's have a look at the dependency queue as well. Because ideally, I don't have to lock these small structures. Ideally, I only have to lock on the creation of the directory structure, which is already done. And then I lock the concurrent operation myself. Maybe I will be able to, because I need some path to create these locks, to change the layout, to even have a lock subdirectory where I drop these locks so I don't have to spill them everywhere, except for the registry stuff, obviously, which needs which needs a lock where I put it right now, I think. Anyway, so let's investigate that. Dependency queue, cargo compile, because then I think I would have killed everything, or basically everything would work now and in future automatically, without locking it kind of internally, because all the work is usually done in work, except for when it's about preparing the directory structures. This is done in advance when setting up the work. Yeah. So what do we have? When scheduling stuff, let's have the dependency queue on the other side. Let's see. Dependency queue, I think that's primarily a data structure, huh? A set of dirty packages which are currently being built, waiting for a call to finish. Hash set k is the key and value. Okay. Queue adds a new package to this dependency queue, which is based on k context. Okay. K is a dependency, and the dependency trait has a context type and allows you to provide dependencies based on that context. Okay. Returning additional dependencies. So that is what a dependency queue is. All right. So we have implementations for this in many places. Manifest. That's a different thing though. Yeah, so here's the implementation for JobQueue. Yeah, I don't think I need that. Let's have a look at dependency queue. Combine, new, queue. We queue something, we dequeue something. Fine. All fine. So the job queue is the thing that executes that. Here we go. This is where I get the information that I should need to do any kind of locking. And this should be on per package, per stage, maybe even. Stages. Yeah, if you assume that these dequeue operations will be in the right order, then I think all I have to do is to take a lock that is locking the package. And the package is a package type. Let's see what this thing knows. Struct package. Oh, there is a core package, package ID. Not interested. Package ID spec, not interested. Okay, so it's package RS. No, is it that one? There are more. This one. Struct package. Okay, so this has a manifest. Yeah, this is the cargo toml. And the root of the package, manifest path. Obviously, I could lock there. But that's something I do not want. Yeah, so an obvious problem is that I do not have the target path here. This is contained in the work, and there is, well, a stage that is an enum that is really nothing more. It also provides no information. Stage start. Yeah, so I would have to provide, I think to get started, I would just brutally lock this stuff and spill my logs everywhere. I might just spill them in the cargo home if I have access to this, which might not be the case. Might really just not be the case here. Not even that I know. Because the config, that's kind of the cargo home, the related stuff. And I do not have this here anymore, do I? Or do I? JobQueue. Resolve packages, active pending, package IDs printed. No, I do not. Would have been too nice. Yeah, so considering I don't even have that, I could just start out with some silly implementation. I could put it into a temp tier. What about this? Yeah, that's not too silly after all. So I will just generate my path and I will just lock the heck out of this stuff. And yeah, here where you run it, this is where I want to do this. For now, without the stage. By the way, did I just look for enum stage? Where did I find that? Oh, it's in the job queue. Who would have thought? Yeah, so dependency queue, not interested. Yeah, because I want to see if it is possible generally to lock that stuff down and make it work. Because it should be possible. Especially if I do this for every job that runs here. Every single job gets locked. And yeah, execute. Oh, we got a config. Oh, there's the config. Cool, so the config we can use to actually determine the kind of lock that we wish. And we can we determine more? We can get the target dir. Yeah. And we get the configuration for the config as well. Like whether it's debug. Oh no, wait, this is not this doesn't give us a target dir though. Oh, it does. Cool. Target dir, is there more? Yeah, that's awesome. So now I can... Yeah, I don't know about the debug and release stuff though. But it also doesn't matter for now. Let's see. We could have a log per stage or per package. I think I would want to have a log per stage. No, a log per package, so that the stages don't intermix. Huh. Right now, the dequeuing. Probably I would wanna see how this works. So start, package, and stage. I have a debug output here. Build debug. Start. So that's the package and stage stuff. This is the information I have. This is how the logs would be looking like. Start. So they all start. And then what else? Hyper. Oh. So this even has more information, but it's fine. Yeah, the package has information about its manifest after all. Does the package have access to some sort of hash that is used for the fingerprint? Because that's something I would find interesting. But yeah, probably it's not a good idea. I don't know. No. Oh, it can hash itself. Ah. Cool. So we could get the hash. That's the SIP hash. That's the 8. I think that's the 8-byte SIP hash, the 64-bit SIP hash that we see everywhere when we deal with fingerprints. Here is one source for this. And we have a package set. Where is package set used, by the way? Where are you used? Cargo clean, cargo compiler, context. Context has a package set. JobQueue uses that as well. Yeah. Anyway, probably not too interesting to me. I'm interested in learning how the stages work here. Oh, quasi build, custom build. Yeah, I would love actually to just can we finish a package entirely? Does this work? Probably not. Let's look at the code. And at the dequeue code, more importantly. Dependency queue, dequeue. Dep map either. Find where there is no dependency. A package is ready to be built when it has no null unbuilt dependency. If none is returned, then no packages are ready to be built. Okay, so then it removes. Where does it remove the dep? Finish. At some point it must remove items from the dependency list here, huh? So here it first tries to find one that is sufficient. No dependency. If it has one, it gets it off. It gets the data. Does some dirty fresh checking, puts it pending, and then when it's called finish, then I think it removes it from the pending map, huh? Yeah, it does. Then it updates its mappings. I still wonder where this depths thing is handled. After all, this is the one that is not interested in. Depth map. Where is depth map handled? So probably here is where it removes this dependency from all the dependencies in the dependency map. So if you build something that everybody depends on, we remove it from all of them. So it's kind of a so it's kind of a very duplicated structure, which might be good for working on it. I don't know. Anyway, doesn't matter. Totally doesn't matter. Not to me. Question was, what do we get from here? We get fresh, key, and data. Freshness. Key is the... What's the key? It even unpacks it more. So the key is a tuple for him of something and a stage. Okay, do we have a queue? Yeah. And queue is here. So here we see what the type is. We have the package ID. I think the package ID might even be config we don't need right now. Context we don't need. Registry, no. Let's kill a few things. Package ID, is this by any chance the hash in hexadecimal? No. But that could be something useful when doing the log stuff. Let's try. So anyway, package ID and stage, that's the key. Yeah. So it's putting on different stages. For particular packages. And then it pushes the jobs on there based on freshness. It only adds these stages if they're actually required. Okay, so that's how that is working. So we have, let's look at the stages again. Start. Current stage of compilation for an individual package. This is the second layer of keys on the dependency queue to track the state of where the particular package is in the compilation pipeline. Each of these stages has a network of dependencies among them outlined by the dependency implementation found below. Each build step for a package is registered with one of these stages, and each stage has a vector of work to perform in parallel. Okay, to perform in parallel even. Well, fine. Let's just say we just perform this stuff in parallel by one thing at a time. Per package and stage. Yeah, so I think this is what we have to do. Yeah, let's just get started with that. Let's not think about it for too long. After all, the Rust C stuff log didn't work. Now we log at a much better spot, and I think that should be something, worth something. And we can put it into the target dir even. So we can create the logs dir for us, which will be done by the log implementation, if we use it right. Yeah. Okay. So util cargo lock. Here we go. Now I get my registry again. No, not this one. This one. Just to get my default thing. And now we generate a nice name. So for execute, this is where we want it. So here we get the lock. Actually, we get the lock per here inside of that one. We want to do this. Run in run, because the run will schedule it, right? Package ID clone pending, because where is it moved? Here. And this is where we want to get the lock kind. Let kind be, just drop this here for now. Can we, oh, we have a cargo result, that's beautiful. So we can try on this. Lock kind, we just cache this. And the path for the item we can generate on the fly. And do we get the config here? No. We do not get the config here. That's very sad. But it's our own one, so I might just add the path. Let's see, config target dir gives for a package. That is totally awesome. Yeah, cool. But I think it might be a problem to use this package, huh? Because then we would drop it all over the place. The target dir. Huh. Because that should be done for the root package only, should it be? I'm not sure. We might add some debug code to tell us what we are trying to do. Lock. Let's add some debug code here. Debug. About to acquire lock. File lock, which is here. Self path. Self inner path. Display. Okay. All right. This is the debug information. And now back to this one. So we get a package stage freshness. Oh, we get the config. Nice. Yeah, so nothing to worry about. So we do actually, yeah, we move the lock, right? I'm not sure if we can actually move it. I might just create everything. Let lock path be config target dir for our package. Then we join two things. First we join logs, just for the fun of it. And then we join the package ID. ID, there we go. What was I thinking? Yeah, so config target dir, that's something we put up here. And probably we want to format that as well. I don't know what the ID even looks like. Maybe I want a package name too, so that it's more human readable. Yeah, let's see what the package ID is looking like first, before I going crazy on it. And we call it log. Why not? And that is that. Good. So now we have everything we need to get this log path. This will be moved there. And this is something we obviously do in the thread. So it's where we move it. So job run, this is what does the actual, what does it. And yeah, I think that the only thing we can do here is send stuff. What's the pool? Does it use the thread pool implementation? Yes. Creates thread pool. And let's get the docs instead. Execute. I could just enter this here, right? Let's see what kind of function it wants. Fn once doesn't return anything. Okay, so if you wanted to return anything here, then we have to do it within the job run. And job run returns a cargo result, I hope it does. So yeah, we cannot lock this. We will fail. Fail to lock. Yeah, let's name it. Info start PKG stage. This is what we do here as well. PKG. I don't know if the PKG ID is what's printed. Let's look at the configuration. Display. Summary. Package ID. What's the package ID? Seems to be summary package ID, huh? No, that's the manifest package ID. So it's something else again. Or is it? Is it not? The summary. Manifest summary. So is the manifest package ID the summary package ID? Show me. It is the summary package ID, so that's all the same. So this means the package ID that I have here has spaces in the name. We shouldn't care about that. I mean, it's okay, but it's probably not the most beautiful package ID ever. Is there something else? Like something that is not containing spaces? Yeah. Anyway, we don't have to care. failed to log. So it just means I can print the ID here as I like it. And I can't try on this one. Job run, I actually want to put... Yeah, so that's returning a result. Actually, the result I want to keep here. I want to convert it into a cargo result that returns nothing, so that I can then just use these types. These types directly. I'm thinking result or that result. Does that work? I think that should work. Do I have or here? And or, which, oh yeah, that's it. So I could map it so that T becomes a U. Okay. The result is compatible. Okay, that's how I could do it. Yeah, let's do it. So we chain the error. And then, yeah, I think chain error comes last, huh? So we map it here so that the result type is just a unit and not, oh wait, what's the result type of my log? Why do I have so much stuff open? I don't need that anymore. Log. Oh, it is compatible already. Awesome. No mapping required. So let log result be this. So it returns res if the result is okay, otherwise returns error value of self. Yeah, let's see if I get this logic right. Yeah, actually, yeah, it must be an and, huh? So x, y, x, and y. So that's giving me the late error. This is okay, and this is an error. So what is, it's early error. What is if both are okay? Different result. Okay, that's exactly how I would expect it to work. So it's and. Actually, it's and then. Yeah. So it's log result and then yeah, that is that. And what about the semantics? We are sending this. The sending can block. Actually, I want to drop this log sooner. Right after I run. Let's see. So we have log. And then the good thing is that I do have, which returns a function returns a result, that I do have a functor here. Does it get anything? It gets the, yeah, the OK type it gets. And it can also be used for conversion, makes sense. No, wait, the error stays the same. The type can be converted. Yeah. Okay, doesn't matter, we don't care about that. And then we get whatever result we have, but we don't care about it. So we run the job. This one is what we want to return, but after the job has been run, we want to drop the lock before that send has a chance to block us potentially. I think that's the thing. Oops, wrong spot. Here, so let's put this onto a new line. This is the send. Something is wrong now. And then has no closure. So, and then run the job and drop the lock. Yeah, so we get the result, return the result, but before that we drop the lock and then it can be sent. Drop FL. And this lock thing, yeah, that's fine. Lock, and then, so if that isn't there, then we will just fail with that error. Fail to lock package operation. Fail to lock package at stage. This one. So that's, I think we have to use the ID here because that's going to a separate thread and this package probably isn't sync or send or whatnot. And then we just print the stage, which we should have. Maybe we have to clone it. No, that's here already. Good, so possibly this compiles. But this is the semantics I could imagine here. Logs, so we get a new target subdirectory here. And we have to check what happens if, yeah, we have to check a lot of stuff. Probably if we try the tests now, lots of them will break. But first, I'll compile this. 181. I will compile this and see if it works for me. Because if it works for me, then we have solved the problem. And the test will then just have to be adjusted, or, you know, then we have a basis, because that's kind of the proof of concept. Lots of locking happening, but if it works, it works. And if it can, if it can deal, then it can also deal with everything. That's the amazing thing, without having to lock stuff. This also means we never prevent work from being duplicated, but we prevent stuff from getting into each other's way. Possibly. Probably that is totally spotty, but yeah, more locks are better, right? Failed to lock. Oh yeah, human is not there. We also added some new stuff into the lock module, which might also blow up right now. Rusty JobQueue. Template access to config, but no field with that name was found. Self config, which is just config. And then this function takes one parameter, multiple were supplied. Human, we want to format this. Like that. And yeah, maybe it works now. That's kind of the two errors that I see here. Nope. Getting there. Oh, display is not implemented? Really? That's weird. How do they, but they do it, right? They print start, they print the stage here. Excuse me. You're doing it. Oh, that's the debug printing. Fine. I shall do the same. Nope. Not quite. Method name chain error not found. Sure, we need to import the trait. And let's see. Lock kind. Where is that? 180. Capture of move. Oh yeah, it tries to be captured. Lock kind. But we just use it once. What's the problem here? Lock path. Capture of moved value lock path. Lock path moved into closure here because it has type. Yeah, right, but capture of moved value. But we are in the move thing. We have it here, right? Excuse me. It can move it can use it. It has been moved in there. What the heck? That's a bit of a problem. So do I have to... Oh, yeah, it's in a loop. This is why we just have it once. And we want it on a per loop basis. Actually, we can just get this stuff once and then we duplicate it the hell out of it. Let lock kind be lock kind clone and let lock path. Yeah, sometimes I forget the loop, but makes sense. Lock path clone. Good. So now we have enough instances of that stuff around to make it work. And if I can type, maybe one day this will compile. And I'm still, I'm curious. If we are lucky, this works. But we must be very lucky. Maybe we are. Cool. So apparently this now has a chance. Let's play a game. I want to have my own version of this. Maybe at some point even add sound. This game is so simple that you can try the basics with it. And that's the awesome thing. And it's probably more fun than doing YAML, even though at some point I will have to get back to YAML, obviously. YAML is a requirement, yet... Oh. Done. I also want to have a bit of fun because YAML wasn't fun to me that much. Maybe there is a way to have both. So, it compiled. Awesome. Let's try it then. Let's start fresh and J2 it. So, different packages, same dependencies, and it will probably abort very, very soon if it doesn't work. So it's busy with all cores. That's quite amazing. And it didn't yet fail. I think it might have failed. So 4 cores are busy. Maybe it's that locking or something, but also that shouldn't happen because we dropped the lock in any case. But maybe it, I mean, it's still busy, right? Let's not get, and it's still doing stuff. It's amazing. We are still in the game. Maybe this works. Oh my God. And we are duplicating work here. Let's not forget that. That's not optimal at all. Because we compile stuff multiple times. That's at least what I think should happen. But right now, probably because of the locking stuff. Yeah, let's have a look at the locking stuff. Let's see. We are in target, locks, and here, syntax. Yeah, we don't use the stage just yet. This is why only one stage can be done at a time. Ooh, should look at this. So that's dangerous. Yeah, so we can't use the ID here. That's something we have to fix right away. Probably this log file will still work. But, and I don't know why it has a size. Google Discovery. Is a directory. Ooh. Ah, because there are slashes in there. Shit. So that's terrible. Still, it works. There is a log file deep down in there. There it is. Yikes. But hey, it still works. And yeah, we are still busy, are we? Yeah. I have one guy being busy. No, two. No, just one. One guy. And probably you want to lock it per stage as well. But maybe not. I don't know. We'll see. Oh. But that's a different thing. That's okay. Found possibly newer version of create libc with syntax. Okay, that's yet something else. Perhaps this crate needs to be recompiled. Oh, crap. And now it tries again. See, we had one guy who was totally blocked. And he tries again. So YouTube failed. And now is discovery time. And it seems that these locks were held for quite a while, huh? Huh? Yeah, it apparently drops it at the right time. Though, okay, let's work. I mean, we are getting somewhere. That's better than before, even though it still doesn't work. Damn it! And I wonder who's saying this. Found possibly newer version. Who's saying this? Not cargo, it's Rust. That's weird. Okay, anyway, we're getting somewhere. We might lock per stage. There's still options. So the ID we don't want. We want the name and the version. And could be local or not, right? So manifest. Package ID, source ID as path. Yeah. Actually, we should use the name and the hash because that does the right thing already. Is there an easy way? No. We convert it to to a hexadecimal string. That's what fingerprint does. Zip hasher? No. Hash. Wherever the hashing is done, it doesn't show me. Hex. Fingerprint resolve. Oh. So this is returning a string. File time. Damn it. Short hash. Oh yeah. Here's where it happens. With keys. Oh, and then it uses a tuple to hash this thing. Okay. Yeah, we can just use the short hash. util short hash. And get a string. 2 hex. Oh, see. That's interesting. Converting all the portions into a byte, then into a slice, and then 2 hex. That's amazing. Oh, it's Rust serialized 2 hex, so that's the 2 hex trait that does it. I see, and probably this one wants to have a byte slice, so that's how that works. Nice, I like it. And that's also static here. Awesome. Very interesting. Yeah, so we will use the short hash. util short hash to get a package ID that we can use. Package name and package hash. Now we can't use the package here in the thread. No. Package name is pkg name. Let pkg hash be short hash pkg. And we are done. So, oh, the log path, sure, it is. Actually, look at that. We can create the log path just once. Let's see. It's now called package name and hash. Short hash pkg. So this is how this should be done. Good. So now we have a proper log name. And that failed again. No, wait. So the second one worked. The first one was freaking out. Possibly because, yeah, I don't know. There's only one way to find out. Also, yeah, we might want to try to bring in the stage as well. So a package hash and then the stage. Dot stage dot log. What do you say? Huh? Can work? Is this copyable? Oh no, wait. Anyway, this guy doesn't consume ever. So that's compiler magic, right? This is what I read somewhere. Good. So we should be fine now. Finer. But let the build decide that. We are 55 minutes in already, which is long enough, but we shall see if that works in the next when we try that. Which is pretty cool. We shall see soon. It will say done eventually. It didn't abort yet. Maybe it would even be better if you would have an or in here so that it could tell me as well if it failed, huh? It's done. Okay. The scoring thing is super annoying. I wonder what happens there. Anyway, let's do it. J2, the big moment. With a little bit of a lot of luck, it will just work now. Okay, so all CPUs are busy and it's already fading. So per stage doesn't seem to be a good thing because we don't get that far now. Okay, so here's the stage-based thing. And no luck. How do we fail? How do we fail? Tell me. Do we fail just because of some actual failure or is it something else? Probably something else. So there's still one guy busy here. One Rust C compiler, and I think we are waiting for this one. And it keeps going. Failed to lock trade object. Look at that. It couldn't get a lock? Unfortunately, it doesn't give me the cause stuff here. That's interesting. But it should wait on these, yet it failed. Trade object v0.1 add stage libraries. So this lock it couldn't get. How come? So clap, solicit, Rust C serialize. Damn it. Well, I think it's kind of a good thing because it's a lock specific error, unexpected. But this also means we kind of work because we didn't run this then, huh? We have lock, and if it is okay, then run the other thing that will produce a result that will then be the error result. But only run it if we have a lock. So fail to lock this at stage libraries. Okay. Probably you want to do this. But I wonder if I can convert to lowercase with the format. FMT probably has all the information I ever wanted. Lower hex, well. Upper, no. No, can't do. But I could convert the display. Well, display stuff doesn't work. If it has a toString, yeah, probably it has toString implemented, so I could then lowercase this. But also it's not that important. Yeah, the weird thing. Because, oh, now I get it. So cargo stopped working because it failed to lock something, which shouldn't happen because we wait for our locks, right? But it did happen and it failed. But it failed gracefully. And the other one still finishes. And yeah, it's actually working. So I think we improved stuff. Even though it's not yet at the point where it is totally working. So I think this requires more testing, but it shows we are on possibly the right track. So thanks for watching and have a good day.